The universe is vast, filled with mysteries that have captivated humanity for centuries. But among the most tantalizing questions we face is this: are we alone? For decades, scientists have peered into the cosmos, searching for worlds beyond our solar system that might hold the key to life. And now, thanks to groundbreaking discoveries, we've identified not just one or two, but 22 fascinating planets that could potentially support life. These distant worlds, each with its own unique story, challenge everything we thought we knew about habitability. From scorching super-Earths to icy ocean worlds, the diversity is staggering. What makes these planets so special? Could one of them become humanity's next home? Join us as we explore these extraordinary worlds and uncover the secrets they might hold. The journey begins now. Picture a world so close to us in cosmic terms that it feels almost within reach: Proxima Centauri b. This exoplanet, orbiting our nearest stellar neighbor, Proxima Centauri, sits just 4.24 light-years away from Earth. That might sound like an unfathomable distance, but in the grand scale of the universe, it's practically next door. What makes this planet so intriguing is its location within the habitable zone of its star, often referred to as the Goldilocks zone. This sweet spot means it could potentially have temperatures that allow liquid water to exist on its surface, a key ingredient for life as we know it. But here's where things get complicated. Proxima Centauri b orbits a red dwarf star, a type of star known for its volatile nature. These stars are prone to frequent and intense solar flares, bombarding nearby planets with harmful radiation. This raises questions about whether Proxima Centauri b could sustain an atmosphere thick enough to shield potential life from these harsh conditions. Adding to the mystery is the possibility of tidal locking, where one side of the planet always faces its star, creating a permanent day and night side. This could lead to extreme temperature differences, making habitability a complex puzzle to solve. Despite these challenges, Proxima Centauri b remains a tantalizing target in the search for life beyond Earth. Its proximity makes it a prime candidate for future interstellar missions, and scientists continue to study it for clues about its atmosphere and potential for hosting life. As we turn our gaze to the stars, this nearby world reminds us that the universe is full of surprises, some of which may be closer than we think. And speaking of surprises, let's shift our focus to a planet with a very different story to tell. Let's zoom in on one of the most exciting candidates for life beyond Earth, TRAPPIST-1e. This rocky world, part of the TRAPPIST-1 system, has captured the attention of scientists and space enthusiasts alike. Why? Well, it's roughly the same size and density as Earth, making it a prime candidate for habitability. But what really sets it apart is its potential to host liquid water, the cornerstone of life as we know it. TRAPPIST-1e orbits a small, cool star about 40 light-years away, and it's just one of 7 planets in this fascinating system. What's remarkable is how close these planets are to each other, so close that if you were standing on TRAPPIST-1e, you might see neighboring worlds hanging in the sky like oversized moons. Imagine looking up and seeing not just one but multiple planets, each with its own unique features. It's a scene straight out of science fiction, but it's very real. One of the most intriguing possibilities is that TRAPPIST-1e could have a thick atmosphere. While we don't know for sure yet, a dense atmosphere could help regulate temperatures and protect the surface from harmful radiation, creating conditions that might support life. Of course, there's still much to learn. Is the atmosphere nitrogen rich like Earth's, or is it something entirely different? Could there be oceans hiding beneath its surface? These are questions that future missions hope to answer, but let's not forget the bigger picture. The TRAPPIST-1 system is a treasure trove of possibilities, with each planet offering a unique window into the potential for life elsewhere in the universe. And speaking of unique, our next stop takes us to a world with conditions so extreme they defy imagination. Get ready for a planet where the rules of habitability are turned upside down. Now, let's turn our attention to Kepler 452b, a world that has earned the nickname Earth's older cousin for good reason. This fascinating exoplanet is strikingly similar to our own in size and orbit, sitting comfortably within its star's habitable zone, the sweet spot where liquid water could exist. Kepler 452b's host star is a near twin of our Sun, sharing similar temperature and brightness, which raises the tantalizing possibility of a stable climate over billions of years. Imagine a planet that's had an extra 1.5 billion years to potentially develop life, making it a prime candidate for scientific curiosity. But here's the catch: Kepler 452b is located more than 1,400 light-years away from Earth. That staggering distance means that even our fastest spacecraft would take tens of millions of years to reach it. While this makes direct exploration impossible with current technology, it hasn't stopped astronomers from studying it through advanced telescopes and simulations. The challenges of such a vast distance remind us of the immense scale of the universe and the incredible advancements needed to bridge the gap between us and these distant worlds. As we marvel at Kepler 452b's Earth-like qualities, we're also reminded that not all potentially habitable planets follow the same script. Up next, we'll explore a world with a dramatically different orbital dance, one that defies expectations and opens up new possibilities for where life might thrive. Moving on to LHS 1140b, we find ourselves looking at one of the most promising candidates for habitability beyond our solar system. This super-Earth, located about 49 light-years away in the constellation Cetus, orbits a dim red dwarf star. But don't let dim fool you. This star's low activity is actually a good thing. Unlike more volatile stars, LHS 1140 emits minimal harmful radiation, creating a far more stable environment for potential life to thrive. LHS 1140b itself is a fascinating world with a mass roughly 7 times that of Earth. Its larger size suggests a dense, rocky composition, and scientists believe it could have a thick atmosphere capable of retaining heat and supporting liquid water. The planet sits snugly within its star's habitable zone, where temperatures might allow water to exist in its liquid form, a key ingredient for life as we know it. What makes LHS 1140b particularly intriguing is its atmosphere. While it's still under study, early observations hint at the presence of gases like nitrogen or carbon dioxide, which could help regulate surface temperatures and create conditions suitable for life. Even though its gravity would feel much stronger than Earth's, the possibility of a stable, life-friendly environment makes this super-Earth a prime candidate for future exploration. As we wrap up our look at LHS 1140b, let's turn our attention to a planet with a very different story, one that pushes the boundaries of what we consider habitable. Next up, we'll explore a world where the environment is anything but ordinary, and yet life might still find a way. Imagine a planet where vast oceans stretch as far as the eye can see, shimmering under the light of a sun-like star. That's Kepler 22b, a world that has captured the imagination of scientists and space enthusiasts alike. Located about 600 light-years away in the constellation Cygnus, this intriguing exoplanet sits comfortably within its star's habitable zone, the sweet spot where temperatures could allow liquid water to exist. And with a star remarkably similar to our Sun, Kepler 22b has long been a prime candidate in the search for life beyond Earth. What makes this planet particularly fascinating is the possibility that its surface might be entirely covered by a global ocean. Picture an Earth where continents are few and far between, or perhaps non-existent altogether. While that raises exciting questions about the potential for aquatic life, it also presents significant challenges for study. At such an immense distance, even our most advanced telescopes struggle to gather detailed information about its atmosphere or surface conditions. Is the air thick with water vapor, or could there be other gases hinting at biological activity? For now, these remain tantalizing mysteries. While Kepler 22b's watery potential is captivating, it's worth noting that not all habitable worlds are so serene. Some planets face far harsher conditions with temperatures that swing to extremes, and that brings us to our next destination, a world where the heat is almost unimaginable and the environment is anything but Earth-like. Now, let's turn our attention to Gliese 667cc, a fascinating world that offers a glimpse into the complexity of life beyond our solar system. This rocky exoplanet, located a mere 22 light-years from Earth, orbits within a triple star system, a celestial dance that creates a dynamic and unpredictable environment. Imagine standing on its surface and looking up to see not one, but 3 suns lighting up the sky. It's a scenario straight out of science fiction, but it's very real in the case of Gliese 667cc. What makes this planet so intriguing is its potential to support liquid water, a key ingredient for life as we know it. Nestled within the habitable zone of its primary star, Gliese 667c, this planet receives just enough warmth to make liquid water possible. However, the presence of 2 additional stars in the system adds layers of complexity. These stars, while farther away, still influence the planet's climate and stability, creating a delicate balance that could either nurture or disrupt the conditions needed for life. Gliese 667cc's rocky composition is another point of interest. It's classified as a super-Earth, meaning it's larger and more massive than our own planet, but still within the realm of terrestrial worlds. This suggests it could have a solid surface, potentially with mountains, valleys, and even the building blocks for life. Yet, the gravitational tug of war from its 3 stars could lead to tidal forces and orbital shifts, making its environment anything but predictable. What's truly remarkable is how close this system is to us, just 22 light-years away. In astronomical terms, that's practically next door. This proximity makes Gliese 667cc a prime candidate for future study, as advancements in technology could one day allow us to peer into its atmosphere and uncover its secrets. But for now, it remains a tantalizing mystery, a world that challenges our understanding of what it means to be habitable. And speaking of mysteries, our next destination holds an atmosphere so enigmatic it defies expectations. Get ready to explore a planet where the skies themselves are a puzzle waiting to be solved. Now, let's turn our attention to HD 40307G, a fascinating super-Earth that could be a strong contender in the search for life beyond our solar system. Located approximately 42 light-years away, this planet is about 7 times the mass of Earth, making it significantly larger and more massive. But what really sets HD 40307G apart is its thick atmosphere, which could play a crucial role in maintaining stable conditions on its surface. One of the most exciting possibilities is the potential for liquid water. Despite being farther from its star than Earth is from the Sun, HD 40307G lies within its star's habitable zone. Its star, HD 40307, is a stable orange dwarf, smaller and cooler than our Sun but with a longer lifespan. This stability means the planet could have had billions of years for conditions to develop that might support life. The thick atmosphere, if composed of the right mix of gases, could trap enough heat to allow water to exist in liquid form even at this distance. However, living on HD 40307G wouldn't be without its challenges. The planet's larger size means stronger gravity, nearly double that of Earth. For any potential life forms, this could mean denser bones and muscles to withstand the pull. Even for future explorers, the increased gravity would make movement and survival more difficult. Additionally, the thicker atmosphere might create intense pressure at the surface, posing another hurdle for habitability. Yet the possibility of a stable environment with liquid water keeps HD 40307G in the spotlight. Its star's longevity and the planet's potential for atmospheric retention make it a compelling target for further study. As we continue to explore the cosmos, planets like HD 40307G remind us that habitability comes in many forms, some familiar, others wildly different from what we know. Speaking of different environments, let's shift our focus to a world where the surface is anything but familiar. A planet cloaked in ice where the possibility of life might lie hidden beneath a frozen exterior. Kepler 62f is a fascinating world that challenges our assumptions about what makes a planet habitable. Located about 1,200 light-years from Earth, this distant exoplanet orbits a star that's cooler and dimmer than our Sun. Because of its star's lower temperature, Kepler 62f receives far less warmth, making it a cold, icy world. But don't let the chill fool you. This planet has some incredible secrets hidden beneath its frozen surface. One of the most intriguing possibilities is the existence of subsurface oceans. While the surface might be a frozen wasteland, the planet's interior could be warmed by geothermal heat, creating vast reservoirs of liquid water beneath thick layers of ice. This scenario isn't just science fiction, we've seen it right here in our solar system with moons like Europa and Enceladus. If Kepler 62f has similar conditions, it could harbor environments where life might thrive, shielded from the harsh cold above. Another unique aspect of Kepler 62f is its long orbital period. This planet takes about 267 Earth days to complete one trip around its star, a stark contrast to our own 365-day year. This extended orbit means seasons on Kepler 62f would last much longer, creating a dynamic and ever-changing environment. Could life adapt to such a rhythm? It's a question that keeps scientists buzzing with curiosity. As we marvel at the icy mysteries of Kepler 62f, our journey through the cosmos takes a dramatic turn. Next, we'll explore a world that's the complete opposite, a planet where fire and heat dominate the landscape. Get ready to witness the volcanic fury of a world that's as fiery as Kepler 62f is frigid. Now, let's turn our attention to a world that seems almost otherworldly in its composition, GJ 1214b. This distant planet, located about 48 light-years away, is often described as a water world, but don't picture serene oceans or tranquil beaches. GJ 1214b is cloaked in a dense, steamy atmosphere, creating an environment that's both fascinating and inhospitable by our earthly standards. With surface temperatures soaring to hundreds of degrees Celsius, this planet is far from a tropical paradise. Instead, it's a place where water might exist in supercritical states, neither fully liquid nor gas but something in between, floating beneath its thick, hazy skies. What makes GJ 1214b truly intriguing is its atmosphere. Composed mostly of hydrogen and helium, it's so thick that it creates immense pressure at the surface. This oppressive atmosphere could trap heat so effectively that it might prevent any liquid water from evaporating entirely, even under such extreme temperatures. Scientists speculate that beneath this steamy shroud, there could be layers of water or even exotic forms of ice, compressed under the planet's crushing pressures. It's a world where the very concept of water takes on new, almost alien meanings. But could life exist in such a hostile environment? While GJ 1214b's surface conditions are far too extreme for life as we know it, its atmosphere might hold secrets. Some researchers suggest that microbial life could potentially survive in the upper layers of its atmosphere, where temperatures and pressures are less severe. These organisms, if they exist, would likely be unlike anything we've ever encountered, adapted to thrive in a world of perpetual steam and heat. It's a tantalizing thought, life not on the surface but floating high above in a dense, misty sky. As we ponder the mysteries of GJ 1214b, we're reminded of the incredible diversity of planets beyond our solar system. Each one challenges our understanding of what life-supporting environments might look like. And speaking of extremes, our next destination takes us to a world where the winds are so fierce they could dwarf even the most violent storms on Earth. Let's shift our gaze to a planet where the atmosphere itself is a force to be reckoned with. Now, let's turn our attention to HD 85512b, a rocky world that might just have the right ingredients for life. This planet, located about 36 light-years from Earth, orbits a star that's unusually calm compared to many others in the galaxy. That low stellar activity is a big deal. It means HD 85512b isn't bombarded by harmful radiation, creating a more stable environment. Scientists believe this stability could allow liquid water to exist on its surface, a key ingredient for life as we know it. What makes HD 85512b even more intriguing is its position within its star's habitable zone. This Goldilocks region isn't too hot or too cold, making it a prime candidate for hosting life-supporting conditions. While we don't yet know if it has an atmosphere, the planet's rocky composition and stable climate are promising signs. Imagine standing on its surface, gazing up at a sun that's much dimmer than ours, yet still providing just enough warmth to keep things comfortable. But here's something to ponder. 36 light-years might sound close in cosmic terms, but it's still an unimaginable distance for us. Even with our fastest spacecraft, reaching HD 85512b would take hundreds of thousands of years. Yet, despite the distance, it's one of the most Earth-like planets we've discovered so far, a tantalizing glimpse of what might be out there. As we wrap up our look at HD 85512b, let's shift gears to a planet with a far more unusual story. Its orbit defies expectations, taking it on a wild journey that challenges everything we thought we knew about planetary systems. Stay tuned, this next world is anything but ordinary. Now, let's turn our attention to Kepler 1649c, a world that has sparked excitement among astronomers and space enthusiasts alike. Discovered in 2020 by NASA Kepler mission, this planet is often referred to as a hidden gem in the search for habitable worlds. Why? Because it's remarkably Earth-like in size, just 1.06 times the radius of our own planet, and it resides in what scientists call the habitable zone of its star. This means it could, in theory, support liquid water on its surface, a key ingredient for life as we know it. But here's where things get interesting. Kepler 1649c orbits a red dwarf star, a type of star that's smaller, cooler, and far more common in the universe than stars like our Sun. Red dwarfs are known for their longevity, burning for trillions of years, but they come with challenges. Kepler 1649c is so close to its star that it completes an orbit in just 19.5 Earth days. This proximity means the planet is likely tidally locked, with one side perpetually facing the star while the other remains in eternal darkness. Sounds extreme, right? Yet, even in this seemingly harsh environment, life could find a way. The boundary between the light and dark sides might offer temperate conditions, creating pockets where liquid water and potentially life could thrive. What makes Kepler 1649c even more intriguing is its potential for habitability despite these challenges. Red dwarf stars are notorious for emitting intense stellar flares, which could strip away a planet's atmosphere or bombard it with radiation. But recent studies suggest that some planets orbiting red dwarfs might still retain their atmospheres, especially if they have strong magnetic fields or thick atmospheres to shield them. Kepler 1649c is a prime candidate for such conditions, making it a fascinating subject for future exploration. As we marvel at this Earth-sized world, let's shift our gaze to another intriguing system, a planet orbiting not one but two stars. Binary star systems add another layer of complexity and wonder to the search for life beyond Earth. What happens when a planet has two suns in its sky? Let's find out. Imagine a world where not one, but two suns rise and set in the sky, a place where shadows dance in unpredictable patterns and the horizon glows with a double sunset. This isn't science fiction, it's Kepler 16b, a real planet orbiting two stars in a binary system. Located about 245 light-years from Earth, this fascinating world offers a glimpse into the extraordinary diversity of planets beyond our solar system. Kepler 16b is a gas giant, similar in size to Saturn, but what truly sets it apart is its unique orbit around twin stars. One star is slightly smaller than our Sun, while the other is a dim red dwarf. Together, they create a dynamic environment that challenges our understanding of planetary systems. The orbital dynamics of Kepler 16b are nothing short of mesmerizing. The planet circles both stars in a wide, stable orbit, completing its journey in about 229 days. Because the stars themselves orbit each other, the gravitational forces at play are complex, yet Kepler 16b manages to maintain its path. This delicate balance raises intriguing questions about how planets form and survive in such environments. Could a planet like this support liquid water? While Kepler 16b itself is too cold and gaseous for life as we know it, its existence opens the door to the possibility of other worlds in binary systems with more hospitable conditions. Speaking of binary systems, Kepler 16b might remind you of a certain iconic planet from science fiction. That's right, Tatooine, the desert world from Star Wars, where Luke Skywalker gazed at twin suns. While Kepler 16b isn't a desert planet, its dual-star setup makes it the closest real-world counterpart to Tatooine we've discovered so far. It's a reminder that sometimes reality can be just as awe-inspiring as fiction. But while Kepler 16b's two-sun system is captivating, it also presents significant challenges. The varying gravitational pulls and radiation from two stars could make it difficult for life to thrive, especially on a gas giant like this one. Still, the discovery of Kepler 16b has expanded our understanding of where and how planets can exist. It's a testament to the incredible variety of planetary systems waiting to be explored. As we marvel at the dual suns of Kepler 16b, let's not forget that the universe has even more extreme environments to offer. Next, we'll journey to a planet where the heat is so intense it defies imagination. A world where temperatures soar to levels that make even the hottest deserts on Earth seem mild by comparison. Stay tuned as we explore this scorching celestial body and uncover what makes it one of the most extreme planets ever discovered. Now, let's turn our gaze to K2-18b, a fascinating world that challenges our understanding of habitability. This planet, located a staggering 124 light-years from Earth, has sparked excitement among astronomers for its unique characteristics. K2-18b is classified as a Haitian world, a term coined to describe planets with hydrogen-rich atmospheres and vast oceans of liquid water. Unlike Earth's nitrogen-oxygen mix, this planet's thick hydrogen envelope creates a dramatically different environment, one that could still harbor life. What makes K2-18b so intriguing is the possibility of its oceans. Beneath its dense atmosphere, scientists speculate that vast bodies of water could exist, potentially creating conditions suitable for microbial life or even more complex organisms. Haitian worlds like this one represent a new frontier in the search for extraterrestrial life, expanding our definition of what a habitable planet might look like. While K2-18b's atmosphere is too thick for humans to breathe, its potential for hosting life in its oceans has made it a prime candidate for further study. Telescopes like the James Webb Space Telescope are already peering into its atmosphere, searching for chemical signatures that could hint at biological activity. As we marvel at this distant, water-rich world, it's worth noting that K2-18b is just one example of the incredible diversity of exoplanets. And speaking of diversity, our next destination takes us to a planet with a completely different landscape, a rocky, Earth-like world that stands in stark contrast to the oceanic depths of K2-18b. Imagine a world just 14 light-years away, close enough in cosmic terms to spark our curiosity, yet still shrouded in mystery. Wolf 1061c, a super-Earth orbiting within the habitable zone of its star, offers a tantalizing glimpse into what could be another cradle for life. Unlike many exoplanets we've discovered, this one is rocky, much like our own Earth, but with a size and mass that place it firmly in the super category. Its proximity to us makes it a prime candidate for further study, especially when you consider its potential to host liquid water, a key ingredient for life as we know it. What makes Wolf 1061c even more intriguing is its star, Wolf 1061. Unlike some of the more volatile stars we've encountered, this one is relatively calm with low stellar activity. That means fewer solar flares and less radiation bombarding the planet's surface, creating a more stable environment. Stability is crucial when we're talking about the potential for life, as extreme conditions can strip away atmospheres or make it impossible for water to exist in liquid form. But here's the kicker. Wolf 1061c isn't just a rocky world with potential water, it's also tidally locked. That means one side of the planet always faces its star, while the other remains in perpetual darkness. While that might sound like a deal-breaker for habitability, it's not necessarily the case. The boundary between these two extremes could create temperate zones where life might find a way to thrive. Think of it as a planet with a permanent twilight region where conditions could be just right for liquid water, and maybe even more. Now, as we turn our gaze to the next planet on our journey, we're stepping into a world where the atmosphere itself is a mystery. What secrets might it hold, and could it challenge everything we think we know about life beyond Earth? Kepler 186f is a name that stands out in the history of exoplanet discoveries, not just for being the first Earth-sized planet found within its star's habitable zone, but for what it represents in our search for life beyond our solar system. Imagine a world roughly the same size as Earth, orbiting a star that's cooler and dimmer than our Sun. That's Kepler 186f, situated about 500 light-years away in the constellation Cygnus. Its star, Kepler 186, is a red dwarf, a type of star known for its longevity and stability, but also for its tendency to emit strong flares that could challenge the survival of any potential life. Still, this planet's location in the habitable zone where temperatures might allow liquid water to exist makes it a prime candidate for further study. What makes Kepler 186f so intriguing is its potential for hosting liquid water. Water is the cornerstone of life as we know it, and finding a planet of similar size to Earth in this Goldilocks zone is a significant step forward in the hunt for habitable worlds. However, there are challenges. Red dwarfs like Kepler 186 are much dimmer than our Sun, meaning Kepler 186f receives less energy. This could lead to a colder climate, potentially requiring a thick atmosphere to trap enough heat for liquid water to flow. Scientists also speculate that the planet might be tidally locked, with one side perpetually facing its star and the other in eternal darkness. This could create extreme temperature differences, but it doesn't rule out the possibility of life thriving in the twilight regions between the two extremes. The discovery of Kepler 186f marked a turning point in exoplanet research. It proved that Earth-sized planets could exist in habitable zones around other stars, fueling optimism that we're not alone in the universe. While we don't yet know if this distant world has an atmosphere, oceans, or signs of life, its existence alone is a reminder of how much we still have to explore. And speaking of extremes, our next stop takes us to a planet where temperatures are anything but moderate, a world that pushes the boundaries of what we thought possible for habitability. Now, let's turn our attention to TOI 700d, a planet that has quickly become one of the most exciting discoveries in the search for habitable worlds. Nestled within the habitable zone of its star, this Earth-sized planet has sparked significant interest among astronomers and science enthusiasts alike. What makes TOI 700d so special? For starters, it orbits a small, cool M-dwarf star, which is known for its remarkable stability. Unlike some stars that flare unpredictably, TOI 700 star is relatively calm, offering a steady environment, a crucial factor for the potential development of life. TOI 700d is about 20% larger than Earth, placing it in the category of rocky planets that could support a solid surface. But what really sets it apart is its position within the habitable zone, often referred to as the Goldilocks zone. This is the sweet spot where temperatures are just right, not too hot, not too cold, allowing for the possibility of liquid water to exist. And as we know, where there's water, there's potential for life. While we don't yet know the exact conditions on its surface, the planet's size and location make it a prime candidate for further study. Could TOI 700d have an atmosphere? Could it host oceans or even some form of life? These are the questions that keep scientists eagerly analyzing every bit of data. And while this planet offers a familiar Earth-like setting, our next discovery takes us to a world that couldn't be more different, a place where the environment is as extreme as it is fascinating. Stay tuned as we explore this next planetary marvel. Now, let's turn our attention to Ross 128b, a planet that might just be one of the most intriguing neighbors in our cosmic backyard. Located a mere 11 light-years from Earth, this rocky world orbits a quiet red dwarf star, one that doesn't bombard its planets with violent solar flares like some of its stellar counterparts. This calm environment makes Ross 128b a promising candidate for hosting liquid water and potentially life. What sets Ross 128b apart is its relatively stable climate despite being tidally locked. This means one side of the planet always faces its star while the other remains in perpetual darkness. Yet, scientists believe that a thick atmosphere could distribute heat effectively, creating temperate zones where life might thrive. Imagine a world where the twilight regions between day and night could offer just the right conditions for liquid water to pool and flow. At just 11 light-years away, Ross 128b is practically next door in astronomical terms. For perspective, if our galaxy were a city, this planet would be just a short stroll down the block. Its proximity makes it a prime target for future exploration, especially as our technology advances and we develop the means to study its atmosphere more closely. Could this quiet neighbor hold the secrets to life beyond Earth? As we wrap up our look at Ross 128b, let's shift our gaze to a world that's a stark contrast, a planet cloaked in ice where the surface glistens with frozen potential. This icy frontier awaits us next. Now, let's turn our attention to Kepler 438b, a world that's both intriguing and daunting. This exoplanet, roughly the same size as Earth, orbits within the habitable zone of its star, making it a prime candidate for liquid water and potentially life. But there's a catch. Kepler 438b star is a red dwarf, and like many stars of its type, it's prone to frequent and intense solar flares. These flares unleash bursts of radiation that could make the planet's surface a harsh environment for life as we know it. Imagine living under a star that frequently bombards you with radiation. Sounds like a tough neighborhood, right? Despite these challenges, Kepler 438b still holds promise. Its Earth-like size suggests it could have a rocky surface, and scientists have theorized that the planet might harbor subsurface oceans. These hidden bodies of water, shielded from the star's radiation, could provide a refuge for microbial life. It's a reminder that life, even in extreme conditions, might find a way to thrive, especially if it's tucked away beneath the surface. The frequent flares from its star, however, raise questions about the planet's atmosphere. Could it have survived the relentless bombardment, or has it been stripped away over time? This uncertainty makes Kepler 438b both a fascinating and cautionary case study in the search for habitable worlds. And speaking of atmospheres, our next stop takes us to a planet with one of the most unique skies we've ever discovered. A world where the air itself might hold the key to its mysteries. Now, let's turn our attention to GJ 357d, a fascinating super-Earth that challenges our understanding of where life might thrive. Located about 31 light-years away, this planet orbits a dim, cool M-type star, which is significantly cooler than our Sun. Because of its star's low temperature, GJ 357d receives far less heat and light, making it a cold, icy world. But don't let that fool you, this planet might still have what it takes to support life. GJ 357d takes about 55.7 Earth days to complete a single orbit around its star, placing it in the habitable zone where temperatures could allow liquid water to exist. However, the surface of this super-Earth is likely a frozen tundra with temperatures plunging to extreme lows. The real intrigue lies beneath its icy shell. Scientists speculate that, much like Europa or Enceladus in our own solar system, GJ 357d could harbor a subsurface ocean. If this ocean exists, it might be warmed by geothermal heat from the planet's core, creating pockets where life could potentially survive even in the absence of sunlight. What makes this planet particularly captivating is its resilience. Despite its frigid exterior, GJ 357d represents the idea that life might find a way in the most unexpected places. The possibility of liquid water, combined with a stable environment shielded from harsh stellar radiation, makes this super-Earth a prime candidate for further exploration. It reminds us that habitability isn't always about warmth and sunlight sometimes. It's about the hidden, unseen forces that could nurture life in the shadows. As we ponder the mysteries of GJ 357d, let's shift our focus to a world that's anything but cold, a planet where volcanic activity paints a fiery picture of potential habitability. Now, let's turn our attention to Kepler 442b, a rocky exoplanet that has captured the imagination of scientists and space enthusiasts alike. Located over 1,100 light-years from Earth, this distant world orbits within the habitable zone of its star, a region where temperatures might allow liquid water to exist. And as we know, where there's water, there's the tantalizing possibility of life. Kepler 442b is slightly larger than Earth, making it what astronomers call a super-Earth. Its rocky composition suggests it could have a solid surface, which is a crucial factor when considering habitability. But what really makes this planet stand out is its star. Unlike some stars that flare violently and bathe their planets in harmful radiation, Kepler 442b's star is relatively stable. This stability is key. It means the planet isn't being bombarded with life-threatening bursts of energy, creating a more hospitable environment over long periods. The planet also receives just enough sunlight from its star to potentially keep water in its liquid state, though it's slightly cooler than Earth. This might sound like a drawback, but it could actually be an advantage. A cooler climate could mean a more temperate environment, especially if the planet has a robust atmosphere to trap and distribute heat. Of course, we don't yet know if Kepler 442b has an atmosphere, but the conditions are promising. At over 1,100 light-years away, Kepler 442b is far beyond our current reach, but it serves as a fascinating example of what might be out there. Its combination of a rocky surface, stable star, and position in the habitable zone makes it one of the most compelling candidates for further study. While we may not be visiting anytime soon, The discoveries we make about worlds like Kepler 442b could help us better understand what makes a planet truly habitable. As we continue our journey through the cosmos, let's shift our gaze to a planet with a far more unusual orbit, one that defies expectations and challenges our understanding of how planetary systems form. Now, let's shift our gaze to a hidden gem in our cosmic neighborhood, Teagarden Star B. Just 12 light-years away, this intriguing exoplanet orbits a small, quiet red dwarf star, making it one of the closest potentially habitable worlds we've discovered. What makes this planet stand out isn't just its proximity to Earth, but also its promising conditions. Teagarden Star B is a rocky planet, nestled within its star's habitable zone, where temperatures could allow liquid water to exist on its surface. And liquid water, as we know, is one of the key ingredients for life as we understand it. But there's more to this story. Teagarden's star itself is a fascinating character, a dim, ancient red dwarf that emits very little radiation compared to our Sun. This means the planet might not face the same harsh stellar flares that plague other worlds orbiting similar stars. A quieter stellar environment could provide a more stable climate, raising the possibility that Teagarden Star B could be a haven for life. And while we can't yet say for certain what its atmosphere looks like, the combination of its rocky composition and favorable location makes it a prime candidate for further study. As we wrap up our exploration of Teagarden Star B, let's turn our attention to a planet that couldn't be more different, a world where the winds rage at unimaginable speeds, creating an environment as extreme as it is fascinating. Imagine a world orbiting a star so similar to our Sun that it almost feels like looking into a mirror of our own solar system. This is Kepler 1638b, a distant yet fascinating planet located about 2,000 light-years away in the constellation Cygnus. What makes this planet stand out is its position in the habitable zone of its star, a region where temperatures could allow liquid water to exist. And as we know, where there's water, there's the potential for life as we understand it. Kepler 1638b star is a G-type main sequence star, much like our Sun, which means it shares similar characteristics in terms of size, temperature, and brightness. This similarity raises intriguing possibilities. Could the star's stability and warmth create conditions suitable for life on Kepler 1638b? The planet itself is roughly Earth-sized, making it one of the more Earth-like worlds we've discovered in terms of scale. But size alone isn't enough. It's the combination of its Earth-like dimensions and its placement in the habitable zone that makes this planet a compelling candidate for further study. What's particularly exciting is that Kepler 1638b orbits its star at just the right distance, not too close where water would boil away and not too far where it would freeze. This delicate balance is what astronomers often refer to as the Goldilocks zone, where conditions might be just right for life to emerge and thrive. While we don't yet know if Kepler 1638b has an atmosphere or what its surface might look like, the potential for liquid water alone makes it a world worth exploring in our ongoing search for life beyond Earth. And speaking of atmospheres, our next planet takes mystery to a whole new level. What happens when a world is shrouded in gases so dense and exotic that it defies our expectations? Stay tuned as we uncover the secrets of a planet with one of the most intriguing atmospheres ever discovered. As we look toward the horizon of exoplanet exploration, the future holds unprecedented promise. Upcoming missions like the James Webb Space Telescope are poised to revolutionize our understanding of distant worlds. With its advanced infrared capabilities, this telescope will peer deeper into the atmospheres of exoplanets than ever before, searching for biosignatures, chemical clues that could hint at the presence of life. Imagine being able to detect oxygen, methane, or even water vapor on a planet light-years away. These discoveries could bring us closer to answering one of humanity's most profound questions: are we alone in the universe? But the James Webb Space Telescope is just the beginning. Missions like the European Space Agency's Ariel and NASA's Habitable Worlds Observatory are also in the works, each designed to refine our ability to study exoplanets in extraordinary detail. These missions will not only analyze the composition of distant atmospheres, but also map the potential habitability of these worlds with greater precision. The technology behind these endeavors is advancing at an astonishing rate, from more sensitive spectrometers to adaptive optics that eliminate distortions caused by Earth's atmosphere. Every breakthrough brings us one step closer to unlocking the secrets of these alien worlds. What makes this era of exploration so thrilling is its potential to transform our perspective on the cosmos. The 22 fascinating planets we've discussed are just a glimpse of what's out there. Each one offers a unique story, from scorching lava worlds to icy giants, and even those tantalizing Earth-like candidates that might harbor life. These discoveries remind us of the sheer diversity and complexity of the universe, a reminder that our own planet is but a small part of a much grander tapestry. As we continue to push the boundaries of science and technology, the search for life beyond Earth becomes not just a scientific endeavor but a deeply human one. It's a quest driven by curiosity, wonder, and the desire to understand our place in the cosmos. The discoveries we make today will shape the way future generations see the universe and themselves. And who knows, the next groundbreaking mission might just reveal a world teeming with life, forever changing our understanding of existence. The journey is far from over, it's only just beginning. As we wrap up our journey through these 22 extraordinary worlds, one thing becomes abundantly clear: the universe is brimming with possibilities. From scorching lava planets to icy ocean worlds, and from super-Earths with crushing gravity to tidally locked planets where one side is always day and the other always night, each of these worlds tells a unique story. They remind us that life, in all its forms, might thrive in environments we once thought impossible. The sheer diversity of these planets challenges our understanding of habitability and pushes the boundaries of what we consider home. But beyond the science, there's something even more profound to consider. The search for these planets isn't just about finding another Earth, it's about understanding our place in the cosmos. What does it mean if we're not alone? How might discovering life beyond our planet reshape our perspective on humanity, our planet, and even our future? These questions aren't just for scientists, they're for all of us to ponder. Every new discovery brings us closer to answering one of humanity's oldest questions: are we alone in the universe? So, as we look up at the night sky, let's remember that each star could be the center of its own story, with planets as diverse and mysterious as the ones we've explored today. The universe is vast and the possibilities are endless. What will we discover next? If you've enjoyed this cosmic adventure, don't forget to share your thoughts in the comments below. Which of these planets fascinates you the most? And be sure to subscribe for more explorations into the wonders of space. Until next time, keep looking up, the stars are waiting.